Hello, this is Mr. Lee. Today's topic is on quadratic graphs. So before we start, let's just recap a few things regarding this part. So generally speaking, there's three types of equations for quadratic that you need to recognize. The first type is what we call y equals to ax squared plus bx plus c. I call this the fully expanded form. Well, in terms of the features, you find that this version gives you the least information because it only tells you, for instance, A tells you the shape, whether it's a U shape or N shape, right? C is actually the value of the y-intercept, right, where it cuts the y-axis. Other than that, you find that this doesn't shed any much more light on the information. The second type is what we call y equals to px minus q times x minus r. This is what we call the fully factorized form. A little bit more useful in the sense that from here you know what are the x-intercepts, right? The values where your y equals to 0. And the third type is actually your complete the square form. So you go through the series of complete the square steps and then you get to this stage. This tells you actually the turning point, right? Either the lowest value or the largest value. Okay, we'll come to that later. So if you look at part A, you are given a quadratic graph in the fully expanded form. Again, from here you can't say much other than the fact that this is a U shape and the y-intercept value is -6. Well, so from there at least you can get this part out. Okay. So to get the other features, because the question over here wants you to find the axial intercepts, you also need the x-intercepts. So fully expanded form is not going to be useful. We need to continue to factorize it completely. So by factorizing, first take out the 2, and you find that this is not too hard to factorize. You get 2x minus 1 plus x times x plus 3. Okay, you find that in this case, right, how do you make this guy 0? You just take x to be 1. So x equals to 1 is one of the x-intercept. Now if you look at the other factor, how do you make x plus 3 equal to 0? Well, x has to be -3. So this corresponds to the next x-intercept. And with that, you get your points that are necessary already. You have -3, you have a 1, you have y equals to -6. These are the 3 points that the graph must pass through. The question also wants you to find the equation of the line of symmetry. And with this information on the graph, you see that it's actually quite useful already. Because doing a symmetry, right, it must lie in between the two x-intercepts. So if you have a -3 and if you have a 1, right, the average of these two values is exactly the line of symmetry. So that is actually how I get to the fact that this equation is x equals to -1. So with that, you can actually start to sketch the graph, and the graph will look like this U shape, passing through -3 and 1, passing through -6 for the y-intercept. Yep, that's how the graph looks like over here. Okay, that's for part A. Okay, part B, you need to use the algebraic method, and that's where you find the maximum value of a quadratic expression. So here you need to do complete the square. Okay, so in complete the square, there's a few steps you must follow, especially if you're still new to this idea. So the first step, whatever it is, you need to make sure that the coefficient of x squared is a 1. In this case, it's not, right? It's a -3. So what do you do? Well, you need to factorize out a -3 from both the x squared and the x terms, like this. Okay, the next step is actually quite involved, so do follow. Right, so what we are going to do here later is to somewhat pull out a square from the bracket so that the x squared term subsequently will become the x term, like this. Whereas the 2x, or rather the -2x term, right, you find that the x term is gone. It basically gets, and on top of that, it gets divided by 2. So -2x becomes a -1. And what do you do later? Within this bracket, you need to minus off by the constant value squared. Okay, and this will conclude the complete the square process. Do the simplification, and you end up with this expression. And this is useful because it tells you, right, what is the turning point. So when is this going to be maximum? You find that this value is going to be always at least 0. So you're taking -5 minus something that's at least 0. So the largest value this can ever get, right, is when the term I've circled is equal to 0. Okay? In other words, over here, the maximum value occurs when x minus 1 equals to 0. And of course, that means that x equals to 1. So what happens when this x minus 1 squared term equals to 0? The largest value is what remains, and that is a -5. So that's why you find that this one is a negative 5 as well. So how to continue the story? Very simple, right? You know that this graph from the fully expanded form is negative 3 as the coefficient of x squared, so it's an N shape. So passing through this negative 1, sorry, this 1 comma negative 5, passing through the y-intercept at negative 8, you find that the graph will have to look like this. Go up, maximum, come down. It's an N shape this way. Okay, so that's the end of the video for today. Hope you find it useful. We'll see you in the next video.